today. Okay, Ion is still not. It says joining, but she's not joined. It looks like she's tried it 2 different ways. Alrighty. Let's see what's happening on GoGuardian. She is trying her hardest. Her Zoom is just not working for her today. Oh, there it goes. I think she's in now. Okay. Well, while she's trying to get in, we'll go ahead and start. So again, we're going to look at 3.8 and 3.9. Both of them are on population, and it kind of goes along with the calculation worksheet that you did. And I think I already have them in the playlist. Let me make sure. Yeah, it's already in there. Okay, so we're going to watch these two today. Then I'll give you time to, for those of you who haven't done the AP classroom, we'll do that as well. Yay,
Everybody, it's Mr. Smeeds, and today we'll be talking about topic 3.8, which is human population dynamics. So, as you know, all ecosystems have limited resources, and so all populations must hit a carrying capacity at some point. And this was the basis for a theory put forth by English economist Thomas Malthus in 1798. As you can see in this graph, Malthus noticed that human population was growing exponentially, or at its biotic potential. Meanwhile, our food resources were only increasing in a linear fashion. So he predicted that controls like famine and resulting wars would lead to events that became known as Malthusian catastrophes. And he predicted that these would limit human population growth or impose a carrying capacity for humans. What we'll talk about throughout this video is the factors that Malthus didn't account for, such as technological advancement that would alter food supply. So our objective for today is to be able to explain how human populations experience growth and decline. And in order to do this, we need to know about all the factors that increase and decrease human populations, primarily birth rates and death rates. We also need to know that there are global limits to the human population, primarily arable or farmable land limits. And finally, we'll learn a simple formula called the Rule of 70, which can be used to predict how long it takes a population to double in size. Our suggested science skill for the day is describing environmental problems.
Say goodbye to Slack because chat's here and it's inside ClickUp. Everything you need in chat is here.
So as I mentioned in the intro, Thomas Malthus theorized that because population was growing exponentially, but food growth was linear, sooner or later we would have to run out of food to feed everyone, which would impose a carrying capacity on Earth's human population. So one of the flaws of Malthusian theory, though, is that it failed to account for the idea that technological advancements could increase our food supply. And the best example of this was the discovery of the Haber-Bosch process for synthetically fixing nitrogen into ammonia in 1918. So this led to the creation of synthetic nitrogen-containing fertilizers, which would dramatically increase the productivity of our agricultural lands and therefore increase our food supply in a way that Malthus just never could have predicted. So as we can see here, that while the growth of the food supply in the UK was relatively linear for about 600 years, there was a dramatic and exponential increase in the 20th century following the invention of synthetic fertilizers. So this is what accounts for the dramatic increase in food production that Malthus failed to account for. However, the most prominent social biologist of today, E.O. Wilson, has concluded that the Earth will still experience a carrying capacity based on the limits of our farmland, and he and many other leading social biologists have predicted this number will be around 10 billion. So this kind of begs the question, will we find a way to dramatically increase Earth's food supply again? And we don't really know, but this illustrates an important apes concept, which is that predicting Earth's carrying capacity for humans is difficult, because future technology can alter resource availability in a way that just isn't possible for other species on Earth. So because most countries on Earth are experiencing population growth, and population size has a really significant impact on the environment, it's a really important ape skill to be able to calculate the growth rate for a human population. We can do this using two human population measures called crude birth rate and crude death rate. And these are simply the number of births and deaths in a population per 1,000 people. So we can calculate the growth rate by subtracting the death rate from the birth rate and then dividing that number by 10, since CBR and CDR are both out of 1,000, but growth is always expressed as a percent, which literally means per 100. In this example, we have a global CBR of 20 and a global CDR of 8. So if we subtract 8 from 20, we get 12. When we divide 12 by 10, we get 1.2, which means Earth's global population grows by 1.2% each year. And remember, we always express this growth rate as a percentage. Now we have a really simple formula to estimate the time it will take for a population size to double, and we call this the rule of 70. So all you need to do to determine the time it will take a population to double is divide 70 by the growth rate of the population. So using this example of a 1.2% global growth rate, we would estimate then that Earth's population will double in 58.3 years.
Okay, I'm paused it here because that was one of the examples that you had to use. And again, all you had to do was take 70. So you do need to know what the rule of 70 is. And so you had to take in the number from your question 4 when you calculated the population growth rate before you could do question 5, which wanted you to know the rule of 70.
So all we needed to do there was divide 70 by 1.2. So here's a practice problem that involves both growth rate and doubling time. See if you can calculate the growth rate for a country with a CDR of 9 and a CBR of 18. Then use that population growth rate to figure out how long it would take this population to double. So you can pause the video now, work this out, and then when you unpause, the answer will be on the screen.
All right, I'm going to do that. I'm going to pause it and let you do a practice. So practice and see what you get. So there's two things you have to do. First, you have to calculate the growth rate, and then you have to calculate the doubling time. And it's always good to do the practice problems so that you know that you can do it. See.
Now we'll talk about some
Whoops. That
factors that
was
affect human
fast.
population growth.
Hold on.
And this is a bit of. Now we'll talk
Well, it surely does not stay
about
there
some factors that affect human
very
population.
long.
The answer will be on the screen.
All right, see if I can stop it right there. All right, so that's how you should have calculated that. So first you had to get the growth rate, and that was 0.9%, and then you use the rule of 70 to get how many years it will take for the population to double.
Now we'll talk about some factors that affect human population growth. And this is a bit of a review from 3.7, so I'm going to run through these fairly quickly. The higher a country's TFR, the faster they're growing because there's more births. Then we have infant mortality and death rate, which have an interesting effect on population growth. They are technically both factors that decrease population growth since they increase death rate. So CDR would be higher and we would have a lower growth rate. But the problem is they're often associated with countries that have high growth rates. And that's because they're often less developed countries with fewer educational opportunities for women and more agrarian economies that depend on child labor for family income. So while death rate and infant mortality rate technically decrease growth rate from just a mathematical standpoint, they're often associated with countries that have extremely high birth rates, or TFR, which then leads to higher growth. Other factors that can increase population growth rate are high immigration level and increased access to clean water, food, and health care, since those are things that drive down the death rate. And remember that growth rate is just CBR minus CDR over 10. So if our death rate drops, the growth increases since the difference between births and deaths will grow. Factors that decrease the growth rate are death rate and infant mortality rate. So countries that are really underdeveloped often don't get started growing until their death rate and infant mortality rates start to decline to some degree. Then we have a bunch of factors that all decrease birth rate. Since decreasing birth rate takes the numerator in our growth rate equation smaller, all of these factors will decrease growth. These are things like development or affluence. So the wealthier a nation gets, the more their birth rate decreases and the lower their growth rate grows. Then we have increased access to educational opportunities for women, delayed age of first child, and postponement of marriage. All of these are factors that will decrease population growth. So our last topic today is to talk about a concept called standard of living. This is an overall measure of the quality of life that the people of a population experience, and it's based on things like wealth, access to necessities like clean water, stable food supply, shelter, and then even comforts like heat, electricity, and access to entertainment. So the first major indicator of standard of living is an economic indicator called gross domestic product, or GDP. This is the value of all the goods and services produced in a country, and we'll often see it expressed on a per capita or per person basis, which just means we're dividing that total value that their economy produces by the number of people in the population. Then we have life expectancy, which is the key indicator of the physical health of a population. And it's just the average age a person in a population will live to. Now, it increases with access to clean water, healthcare, and reliable food sources. It's really important to know that as a general rule, the higher per capita GDP is and the higher life expectancy is in a population, the more developed the nation is, and therefore the lower its population growth as a general rule. So our suggested science skill for practice 3.8 today is describing an environmental problem. So I want you all to see if you can describe one environmental problem associated with a rapidly growing human population, and then propose a solution that government could take to slow population growth. All right, everybody. Thanks for tuning in today. Don't forget to like population.
All right, so we're gonna watch the next video, but I'm gonna put this as a question in the assignment box before the day is out. So we will look at this next week, but I want you to think about this. So that's going to be a question that you'll have to answer. All right, let's look at then. So that's 3.8. Now we're going to look at 3.9. And the 3.9 had the graph in it that went with that question that you all had to answer. That might.
I knew I was
and
underwater.
They do have the graph in.
I just didn't realize
Canvas,
I
so I
was
don't know
underwater.
Many of you went back and referred to it, but
hey everybody, it's Mr. Smeeds, and today we'll be talking about topic 3.9, which is demographic transition. So today we'll be wrapping up our population unit by talking about demographic transition, which is a model of how the population of a country changes as it becomes more developed. So if we take a look at the graph, we'll see there's 4 basic stages in this model. So the light orange line in the background is going to represent population growth, while the green line represents birth rate and the blue line represents death rate. So we can see in stage 1, countries have very high birth rate and very high death rate, but since they're roughly equal, the population isn't really growing much. Remember that since growth rate is just birth rate minus death rate divided by 10, if we have equal birth rates and death rates, we're going to basically have 0 growth. So in phase 2, the country becomes more developed, so it has more access to clean water and healthcare. This causes death rate to decrease, but birth rate remains high, so the population grows. Then in phase 3, the birth rate begins to fall as family income and educational and economic opportunities for women increase. Population is still growing, but the rate of growth slows quite a bit as birth rate comes closer to death rate. And then finally in stage 4, both birth rate and death rate are quite low, so the population growth slows to close to 0 and may even begin to decline. We'll talk more about the different indicators of these phases and what they mean for a country's development throughout this video. Our objective for today is to be able to explain the process of demographic transition. In order to do that, we need to understand what development from a pre-industrial to an industrial economy looks like and what it means for the birth rate and death rate of a country. We also need to understand that developing or pre-industrialized nations usually have higher infant mortality rates, as well as more children in the workforce, primarily in agricultural farm work that provides the family with income. And then our science practice for today is explaining environmental concepts, processes, and models in an applied context. So before we talk about the actual steps of demographic transition, we need to go over what industrialization is. So it's the process of a country transitioning its social and economic systems from an agrarian-based society to an industrial society. That means one based on farming for food and for income to one that's based more on manufacturing of goods and providing of services for income. So pre-industrialized nations, sometimes referred to as least developed nations, have not really started the transition of industrialization yet. They're typically very poor nations where citizens have very low incomes and often grow their own food and earn their income by selling excess food. Since access to clean water and healthcare is low, infant mortality rate and death rate are very high in these countries. TFR is also high due to factors such as lack of educational opportunities for women, the need for replacement children, and also the need for children to provide this agricultural labor that we mentioned earlier here. Then we have countries that have begun industrializing, and we often refer to these as developing nations. They have decreasing death rates and infant mortality rates, increasing GDP, but there are still portions of their population that are living in agrarian societies. And finally, we have fully industrialized or developed nations. These are ones who've completed this transition and they have low death rate and infant mortality rates, very high per capita GDP, and very low TFR. This map of the world here can help us get a better sense for the development status of different countries. And so we can see in blue, we have the US, Canada, Australia, most of Eastern Europe. These are all what we would consider developed nations. So they've completed the transition from agrarian society to industrialized society. If we look at the yellow, though, we'll see that most of the world is actually in the developing stage, meaning that many parts of these countries have transitioned to more wealthy manufacturing and service-based economies, but portions of these populations are still living in agrarian societies. And then finally, we have much of Africa and portions of Southeast Asia that are considered least developed or early in their industrialization. And this means that the majority of their residents are still living in agrarian economies and have not yet made the leap to industrialization. Now we'll talk about the 4 stages of demographic transition, starting with phase 1 or stage 1. In stage 1, a country has a high infant mortality and death rate, and this is due to lack of access to clean water, stable food supply, and healthcare such as hospitals and vaccines. TFR is also high due to lack of access to educational opportunities for women, access to family planning and contraceptives, and then that need that we discussed earlier for child labor to provide income for the family. Because CDR and CBR are both so high, the country has a stable population without much growth. It's important to point out, though, that there are virtually no countries in the world that are still pre-industrial. So while many nations are very poor and are very early in their development, essentially every country has moved from stage 1 into stage 2 and is growing to some degree. Next, we have stage 2, which is where most of the world's population is currently. In stage 2, modernization has begun, and parts of the country are making that shift from an agrarian economy to a manufacturing-based one. And this brings increased wealth and access to clean water, a more stable food supply, healthcare access for more people, so more children are surviving, they're getting vaccines, they're getting the nutrition they need. So we're going to see infant mortality rate and death rate drop pretty substantially. However, TFR remains high since educational opportunities for women often still lag behind men, and access to contraceptives and family planning are slow to become available. There's also the need for parts of the country to still rely on agriculture for their own food needs and their income, which is going to cause them to have more children to provide that labor and that income that they need. And then there's an important concept called population momentum, or this idea that there's kind of a generational lag time, meaning it takes a long time for culture and societal norms of having a lot of children to shift. So it takes a long time for the changes brought on by education and increased income to make their way throughout a population. So the TFR remains high for about a generation, which could be decades. And so TFR is going to remain high through much of stage 2. Because TFR remains high, but birth rate has declined, these countries experience rapid population growth. These are countries like India, Brazil, China, Afghanistan. And then if we look over at the right, we have some indicators of stage 2 countries. So even though they've started their development, they're typically going to have lower per capita GDP or lower per person wealth. And they're also going to have lower literacy rates and lower educational opportunities for women.
Deal can hire, manage, pay, and develop a global workforce,
Don't you just love
all
these
while staying
commercials?
compliant.
Next, we have stage 3 countries, which we would consider developed nations. In these countries, modernization has increased family income substantially, decreasing the need for children to provide labor and income. TFR also declines due to increased educational opportunities for women, delayed age of marriage and first child for both men and women, as they spend more time pursuing education and careers, and access to family planning and contraceptives become far more widely available. In stage 3, growth slows down as the CBR drops closer to the CDR. So birth rate moves closer to death rate. So these countries will typically have a TFR that's closer to replacement level of 2.1. They have low, stable growth that is slowing down, getting closer to zero growth. They also have very high per capita GDP, long life expectancy, and other indicators of affluence such as long educational lifespan for women and just an overall higher standard of living. If we want some examples here, we have the United States, Canada, and much of Europe. And finally, we have stage 4 countries that have become so affluent that TFR has actually declined below replacement level fertility, and their populations have started to decline. So as economies become highly modernized and family income rises further, families are just having far fewer children. They're spending more time pursuing educational and career opportunities, and this leaves less time for raising a family. It also delays the age of marriage and the age of first child, and all of these factors lead to a lower TFR. If we want to look at indicators of a stage 4 country, they would have the highest per capita GDPs in the world typically. They're also going to have very high life expectancy, meaning that a large portion of their population is elderly. And they're also going to have TFR that is below replacement level, so below 2.1. Examples of these countries would include the United Kingdom, Germany, Italy, and Japan. Now we'll take a look at this model of demographic transition that can help us kind of visualize how the growth rate changes as a country develops. So if we start out on the left here, in phase 1, countries have such a high birth rate and death rate that growth is essentially 0. And if we were to look at a population age structure diagram, they're going to have a dramatic pyramid that quickly pulls in towards the center because the death rate is so high that many infants are not even surviving into their reproductive years, and many of the reproductive age individuals are dying before post-reproductive age. So this is going to give us growth that is slow or non-existent. Remember, though, that there aren't really any true stage 1 countries in the world, so even the very poorest nations on Earth have infant mortality rates and death rates that are lower than their crude birth rates. So we don't see populations that are this underdeveloped. Then we have stage 2 countries, and these will start to industrialize, which brings clean water, stable food supply, and healthcare to much of the country. And this causes death rate to fall rapidly. So if we look at the graph here, we'll see that the blue line, the death rate, will fall dramatically in stage 2, but birth rate stays high. And remember, this is for that reason that we discussed, which is kind of the idea of population momentum or generational lag time. So it takes a while for women to get increased educational opportunities, and it also takes a while for societal and cultural norms to change to normalize having fewer children. So we maintain a high birth rate all throughout phase 2, even though the death rate is declining substantially due to increased access to healthcare, food, water. And as a result, we can see our population in the background. This growth rate is rising steadily. Now, if we go down and look at the population pyramid, we'll see a pretty nice upward triangle or pyramid here, with our largest group being the pre-reproductive age cohort at the bottom. And that, again, is going to indicate rapid increase in population, rapid growth. Now, if we look at stage 3, the major characteristic of stage 3 is that we have a low death rate because people are getting access to clean water, they're getting access to healthcare and vaccines, but the birth rate starts to fall, and that's the real marker of stage 3 beginning. Birth rate falls as that generational lag catches up, meaning it becomes more acceptable for families to have fewer children. There's a decreased need for children to work on farms, to provide agricultural labor. Families are spending more time pursuing educational and career opportunities, so they're having fewer children, they're getting married later. And so all of these factors lead to this dramatic decline in birth rate. And remember, since growth rate is just equal to CBR minus CDR, if we decrease our birth rate and bring it closer to our death rate, this number gets smaller, our numerator, so we're going to have a lower growth rate. And we can see that reflected by this light orange line here that represents population. It's still growing, but look what happens to its slope, especially towards the end. It starts to flatten out a little bit. It's getting far less dramatic or less rapid than it was in stage 2. Now, if we look at stage 4, we're in a very highly developed country. The birth rate continues to fall, and it's going to come closer and closer to what we would call replacement level fertility, or below 2.1, which is going to bring birth rate and death rate essentially equal. And if we look at our mathematical equation here, if we have birth rate and death rate equal, this is going to be a wash. This will be 0, and our growth rate will be 0. So again, we have very low birth rate, very low death rate, And so population growth is falling and potentially even declining if we go later into stage 4. In terms of an age structure diagram, we're going to have a much higher proportion of elderly individuals than any of our other stages. And in reality, we would actually probably see the pre-reproductive age cohort start to shrink in and be smaller than our reproductive age cohort. So our FRQ practice today for topic 3.9 is going to involve the science skill of concept explanation, specifically explaining a model in an applied context. So what I want you to do here is see if you can identify the stage of this graph in which population grows the fastest and explain why this is the case. But then I also want you to think back to those economic and societal indicators of the different stages we talked about and try to describe one indicator of a country that's in this phase. All right, everybody, thanks for tuning in today. Don't forget to like this video if it was helpful. Subscribe.
Okay, we're going to leave that there. All right, so I did want to show you that those graphs, pictures are also in your Canvas. Whoops, don't want that. Okay, hold on. Let me come out of. All right, let me stop sharing for a minute because right now I'm in the grade book. All right, so go to Canvas and look at those last couple of units in Canvas. We are going to, like I said, try to finish this up because that was the last module in Unit 3, and we need to start moving on. So I would like for you very much to, all right, so let me pull this back up. And I'll have to repeat this because half the class is missing. All right, so 3.8 is what he went over. He went over demographics. Make sure that when you look at these graphs, you understand, you can interpret what they say. Because a lot of times they will just, on the questions, they will give you just a picture of the graph and ask you to interpret. They'll give you information and then ask you to interpret the graph. So make sure that you, if you have any questions about interpreting the graph, that you do ask them. So go through, if you haven't already done so, go through each of these, look at that video, and then the one I particularly want you to. All right, so here's where they talk about the doubling time. They do give an example of calculating doubling time and the rule of 70. So make sure that you understand that. And like that was a question on the worksheet that you had to do. And then that graph that he was just going over is also right here in your 3.9. So again, make sure that you understand what the different phases, the upslopes and downslopes are, what they mean, what is probably going on during that period of time. All right, so use this time to go through those. And while you're doing that, I'm trying not to go too far ahead because, like I said, half the class is missing. But we do have to step it up. So more than likely, there'll be a Unit 3 test next Wednesday. Oh, no. Y'all have Shine next weekend. Are y'all going to Shine? Okay. Sometime next week. I will schedule it for Wednesday. I'll put it in the AP classroom again. And if you go to Shine, good. If not, you have access to the test when you're done. Okay, I'll do it that way because, like I said, we do need to move on. So let's plan for that to be an activity for next Wednesday. But if you, like I said, if you're not in class, it's just going to be in the AP classroom. I'll create the exam in the AP classroom, and that way it's assigned and you don't need access from me to get into it. All right, so you all work on that. I'm going to work on putting those questions up for you. And let me see if they're different to the one that is in the AP classroom. If not, I won't repeat them. I'll just put it in the AP classroom. All right, stop sharing. So again, if you all would go through, I came off too quickly. There is a study guide. Let me share again. All right, if you go to the next section, there is a study guide. So make sure that you go back and cover that. So we've covered a lot of stuff again in this. We've talked about the generalists, we talked about survivor curves, carrying capacity, population growth, and then we just finished going through age structure, fertility rates. He had a lot of initials. So make sure that if you're seeing these initials that you understand what they are. They don't always say the country's growth rate, the country's death rate. They just see CBR and all that kind of stuff. So make sure that you understand um, the initials. Okay, so click on each of these topics so that you get the drop down window so that you understand what is required of that unit. Okay. All right, so definitely look at the pointers of how they will pose the questions on the AP exam and what you'll be expected to do. So always look at the tip pages when you get a chance. Okay. All right, so I'm going to leave you to do that. I'm going to check the AP classroom and those who are not present will have to catch up. Why is it doing this to me? All right, so what I did instead, again, I didn't assign the videos for you to watch because we've already watched them. But I did assign the topic questions for 3.8, 3.9, and the progress check questions. So all of those have been assigned in the AP classroom. So again, not the videos, just the questions for 3.8, 3.9, and the progress check. And then what I'm going to do is go ahead and put an announcement so that those, because since like I said, half the class is missing, they know what to check and to check the study guide in preparation for a test. So I will review with you on Tuesday and we'll technically be preparing for test Wednesday. Okay, I'm going to share. And again, I don't know what it looks like when you all go in, but this is what it looks like when I go in. So I've assigned the topic questions and the progress test question. It should say Unit 3 MCQ and FRQ. That's what you'd be looking for as far as the progress check question is concerned. And then what you can do too in preparation for the test is to go back through and look at all of the questions that you've already done, because what the exam thing does is it pulls questions that they don't create new questions. They pull questions that have already been asked. So when I pull together a test, it's usually from questions that you've seen already. So go back and look at the questions that you don't have. MQ, let me see. Unit 3. Says it's already assigned. Maybe refresh your page. Because it told me it's already, I can't assign it again because it's already assigned. Isadora, do you have it yet? Okay. Yeah. I don't think the internet likes all this cold. Internets are acting. And I think they're upgrading too. I got an upgrade on this crazy thing called Windows Copilot. So I have to figure out what that is. But there are upgrades going on. Okay, good. All righty. Okay, so that's all you have for me today. So we're looking at 3.8, 3.9, just the topic questions and the progress check. And I'm going to put that in a summary in the announcement so that those who are not here know that that's what they need to do. Okay, so I summarized all of that as an announcement on your home page. And Isadora, I'm looking at those two worksheets now. Okay, I'll check those as well. Um, on the carrying capacity worksheet, quite a few of you answered question 7 with species, and it did say species, but it also said that carrying capacity is also impacted by the availability of these decomposers, and was the answer that they wanted in that space, because they also went through all of the other issues in the sentence. So other than species, they specifically wanted you to say decomposers. And I just point that out because a lot of you said that. So species is not technically wrong, but the most right answer was decomposer. Without decomposers, nothing would break down. Everything that dies would remain on the surface of the earth, and that would not be a very good thing. So decomposers are extremely important to our ecosystem. Okay, I put a link in the chat to share a page with you before you go. So check that link before you go. It has all of the, while you're reviewing, it has all of the different diagrams that you need to be aware of for in preparing for and calculations as well. It's blocked. Okay, let me check on where. Go Guardian. Okay, hold on one sec. Come on. Yes, you should do those. Gee, I don't know why it's blocked because it's not giving me a blocked way to unblock it. I'll check on the link and see if I can't get someone to unblock that site for you. But I'll share the link in the assignment category, and then because it's not giving me normally I get this big banner at the top where I can unblock it, and it's not letting me do that. But anyway, back to looking at this page. So I'm going to put the link in, and then you can look at it maybe on your own, not while you're looking at Zoom. And it just has all of the pictures and things summarized on one page that you need to be familiar with. But I'll put it up again on Tuesday when we see each other so that we can go over this page, go over all these diagrams and activities. But just copy that link and I'll put it back up. All right, folks, time is up. So you all have a great weekend and see you Tuesday. Bye. Stay warm.